All right, hello, let's get started. Good morning, everybody. Glad you could make it. It's 8:30. I had to run down here. I was in the speaker's lounge. Time got away from me. This session is DirectX Graphics Development with Microsoft Visual Studio 2012. If you have been paying attention to the Build Conference, you'll realize that we have a preview of Visual Studio 2013. Unfortunately, this demo does not cover the features of Visual Studio 2013. So if you're interested in those features, I would recommend that you go online and download the preview copy and take a look at some of the graphics updates that have been made. For example, some of the debugging tools have been made faster. There's some other things out there as well. There is a talk on Wednesday. There was one on Wednesday that should be available for streaming by Tarek McClure, the GM of the Visual C++ division, and he's got a talk on what's new in Visual C++ or Visual Studio for the C++ developer. So have a look there. And then today at 9 o'clock, Herb Sutter talks about the future of C++. That will be live streamed, and that will be followed at 1:30 with a live question and answer. This is 1:30 Pacific. A question and answer with Herb, Tarek, and some other folks from the C++ program. So if you're into C++ or DirectX or graphics development, I recommend that you tune into those and take a look. So does everybody recognize what this is? This is Halo 4 Waypoint. It's a game that obviously uses 3D graphics quite a bit, DirectX. This talk is not about games. So, we're going to talk about business uses and non-game uses of DirectX and multimedia. Games is certainly one of the things that DirectX is good for, but this talk isn't about that. Having gone through the research for this talk, though, I appreciate even more how much effort goes into making games. So if you make games or do a lot of 3D graphics and physics and things like that, it is really time-consuming. There's a lot involved there. So, when I play these games now, I have a deeper respect. So DirectX isn't just for games. Visual Studio 2012 and 2013, DirectX can help you create unique store apps that stand out from the crowd. It will help you manage your graphics assets, things like images, shaders, meshes. And you can debug with graphic diagnostics, and that is Alt F5. So that is a recurring theme, Alt F5. I'm a community guy, so I spent a lot of time talking to customers and community members. And one of the things that kept coming up is folks did not know how to start up the graphics diagnostics tool, which is a statement on, I guess, how the UI looks around this. So it is Alt F5. So if you want to do graphics debugging, it's Alt F5. So I'm going to highlight that throughout the talk. The other thing that I'm going to recommend you do throughout the talk and at the end especially is if you have questions or have done work and want to share some of your knowledge, I recommend that you join community if you're not already there. There are forums, Stack Overflow, for example. There are things like Facebook where like-minded developers hang out, wikis, Twitter. There are all sorts of places that people hang out. I recommend that you go there and learn from that community and then share what you've learned. So we're going to take a look at an overview of DirectX, and then we're going to build a simple proof of concept app using C++. Then we're going to debug it with the graphics tools, and then brainstorm ways to extend the app. And what's interesting about this app is it's a simulation, and we've structured it in a way that you can go out to some of our websites, including our blog and Channel 9, and find supplemental information on how to extend that application. So what makes a great application? Anybody? So I've taken the liberty of adding some ideas here. Things that you would expect. Easy to use, fast and fluid, aesthetically pleasing. My favorite is it just works. And an example of that is if I'm using an application and I want to save something, then it should just save to where it needs to be saved. It shouldn't ask me where it should save it. It should just go save it so the next time I run the app, regardless of my device, it can pull that saved information up, whether it's a calendar or my song preferences. It makes it easy for me if it does that. Another example is, all my equipment at home for the kids, if it just works. I don't want to be an IT pro when I'm at home. I really don't. So, to the extent that equipment can work, whether that's with a user interface or it's automatic, that's great. Obviously, here, if you've got an App Store app or application, to the extent that you can make your experience unique, it'll make your app potentially more powerful and popular. And obviously, DirectX can help you with that. So here's an example of an app that uses DirectX, and it's relatively popular. I don't know if you have used this Paint program. It's one of the more popular ones out there. And this application also uses multimedia. It's by Fitmaster. It's kind of like it uses your camera to make you do physical activity to hit things that are coming at you. And this application is a virtual lab simulator, and it's an educational tool that teaches physics, chemistry, and some other concepts. And it's unique in that it lets the user manipulate things like this atomic structure. DirectX can help you make your application stand out. I think I've said that. It is a set of multimedia APIs, not just graphics. So think input, math, sound. In fact, the X Audio, if you're interested in the sound component of this, on MSDN Magazine, Charles Petzold, I'm sure most of you know who he is. He's been writing about Windows for quite a while. He has a series of articles on X Audio too. I think he makes a virtual synthesizer and talks about manipulating audio on a computer using those sets of APIs. So if you're interested in that, MSDN Magazine is a good resource. MSDN Magazine is a good resource regardless. The current version is 11.1. So that's the version I'm going to be using. There are previous versions, but this demo concerns itself with 11.1. So 11.1 supports Direct 3D support for Windows Store and desktop apps. And there is Visual Studio tooling for this. In a graphics application, you can see there's a lot of components to a graphics application. We're going to be focusing here today. Our application will not have sound. So I want to show a demo of the Virtual Experiment Laboratory by Gökhan at Netas Telecommunication AS. It's an interesting application. And let me see if I can hit the right button here. There we go. I think I hit the wrong button. This one, yeah. Yeah, I hit the upper button. All right. Finger error. So you can see this is an engaging interface. I can take a look here and try oscillation and see how long this takes with the given weight and the length of cord. Almost. So we used a long rope and a large ball. It took 13 seconds to stop completely. We're going to shorten it and then guess and see how long it's going to take. So if we shorten it, do we think it's going to stop in the same amount of time, shorter or longer? Any guesses? Let's just pick that one. took shorter. I was correct. So it's going to do one more. It's going to make the ball smaller and see what happens. So if the ball is smaller, any guesses on whether it's going to be shorter, same, or longer? Shorter? Should be Jeopardy music playing while it floats there. Oh, failed. So that's kind of neat. I think the other thing that's interesting here is so here you can play around with this. So it's all neat. So I'm going to switch back here by hitting the red button. To create an application like this, you don't have to start from scratch. There are templates available for different DirectX applications. They're provided with Visual Studio 2012. I've been told by the person, the PM in charge of that area, that they've been kind of tweaked for Visual Studio 2013 preview. So if you download the preview, your experience will actually be a little bit improved over 2012. So we have Windows Store Direct 3D, Windows Phone, C++ Win32 for desktop apps. There's a whole selection out there. We have a number of samples on using DirectX in a number of different scenarios. Out on the code gallery, the 2012 samples are forward compatible. There are also things on CodePlex. There are samples outside of Microsoft properties. In fact, there's quite a few out in a community that people have created. There's a DirectX toolkit and the Visual Studio 3D Starter Kit. That is what we're going to use for our prototype today. That is what was used for the last the application demo I showed. So this isn't just something that was created and thrown out there. No one really ever uses. It is something that is used successfully. You don't have to start over with your DirectX application. You can use C++, which means you can use all the C++ logic that you may already have. You can bring that over. You can write other parts of your app in Visual Basic and C#. And hello? Is that better? No. Is that better? Nope. Is that better? Okay. How's that? Yeah. All right. Thank you. Huh? Oh. So you don't have to start over. You can use C++ with the DirectX APIs, obviously. You can write other parts of your app in VB and C#. And I was going to go into an aside. I've done TechEd North America and TechEd Europe now, and asked the experts and talked to a lot of customers. And when I ask people about C++ and whether they use C++, the first answer out of developers' mouths is generally no, they don't. They use C# or some other managed language. And as a C++ PM that works with community, I'm a little puzzled, and I say, well, have you ever used C++? And generally what I'll hear is, oh yeah, I was a C++ developer up until maybe 5 years ago, or 3 years ago, or 4 years ago, but I stopped and I moved to C#. And my next question always is, well, why didn't you say yes that you use C++? As well, I don't necessarily use it anymore, or it makes me, brands me as one of the older people that use C++, and I just don't necessarily use it as much anymore. And what's interesting is there's still plenty of, the work that people are doing with C++ are generally components, right? You wouldn't generally write your entire, app if C# is available or VB is available to do the UI portions. You don't necessarily have to go in, MFC style and write your entire UI that way. That the components and things like that, there's still lots of room for C++ there. And developers, the people that used to do a lot of C++ development, I think have moved away from that because of the components. But there still are a lot of C++ components being written and a lot of code being written out there in this paradigm exactly. So if you're a .NET and a C++ person, you're still a C++ developer. You can combine XAML and DirectX in the same app. There are examples of that out on the web as well. We're not necessarily going to demonstrate that in this sample. And you can develop for Windows Store, Windows Desktop, or Windows Phone 8. You don't have to start big. We don't all start with Halo, right? It takes a long time to do something like that. You can start with a proof of concept, which is what we are going to do. You can work out all the kinks, add new features incrementally. Hopefully this is all very familiar, right? And then solicit feedback. So let's talk about, before I go into the demo here, as a proof of concept for this session, I was thinking about what is a compelling little demo that we could create. And thinking about the simulation program that we saw, I think education is a good example of where multimedia can play a role. And in going down that line of thinking and asking around, the concept of probability came up. So if we were to think about how we would teach probability, one of the first, right after we said, oh, probability, well, you think about die rolling and dice. So in our sample, we're thinking about ways that we could extend that visual lab simulator with a probability package. And the first step there would be to get a die rolling. And so that is going to be our proof of concept. We're going to walk through with C++ and the graphics tools, creating a program where when you touch the screen, a single die rolls, a six-sided die will roll. And we're going to use a graphics toolkit for that. And then, as I will show, we're going to do some code as well. This is in C++. So if you're looking for C#, this isn't the place. I got that feedback at TechEd North America. After saying this was going to be in C++, one of the pieces of feedback was, well, it wasn't in C#. Sorry, it's not. So one of the things I like to do as a presenter is start from scratch. I've sat in the audience and watched code demos before where things are kind of the framework is already pre-created. What I'm going to do here is I'm going to start with the same 3D starter kit that you can download from a sample, from a series of blogs on the web that talk about actually doing an extension of the starter kit. So when you download it, this is what it looks like. I'm going to go ahead and extract it. And we've got it. So is it trustworthy? Yes, it is. And here it is. So when I load it, it should just run. So I'm going to give that a shot. Let's see what we get if we just unpack it. Looks like it's running. Doesn't do anything. Which it shouldn't be. There's nothing there. But it does render a screen and a little teapot. So it looks like something's going on there. So we're in pretty good shape right now. So the other disclosure I'm going to make here is I did not memorize all the code that I'm going to be blasting into this thing. I'm going to be working from a code script that I've got here. And this code obviously was pre-developed. I'm going to talk about the code that I'm putting in at each step, but I'm not handwriting all the code that I'm adding in here. It's error prone. So the first thing we're going to need to do is add a 3D scene to this for our die. And the way we do that is we go into Assets here. We're going to add a new item. Graphics. 3D scene. I'm going to go ahead and call this die. So here we are. We've got a 3D scene. There's nothing in it. I can obviously move it around, but there's still nothing in it. So what I need to do is add a cube. There we go. So we've got a cube. And this, you can see that the editor here, this mesh editor, you can do a whole number of things. I could have dropped in, had I not wanted that, I could dropped in a cylinder. I can have two things there. What's funny is the first time I was messing around with this is, that cylinder, depending upon how you texture it, it begins to look like the master control program from the classic Tron movie. So I guess that dates me. But that's the first thought that came to mind. And then I thought, well, what would it take to make a tribute Tron game? It's like, well, I got to start small. So I'm going to go back to the cube. But there is a cone. There's some other things here. And then, in case it's not clear, I'm showing the rudimentary parts here. This is a simple example. You can get pretty sophisticated with these tools. There's extrusion. There's a bunch of things that you can do with these tools. So I'm going to save. And then what I need to do is we need to load it, which makes sense, right? So we need to, it's relatively simple to load. And again, these examples are, there is a detailed description of what I'm doing here available on the VC blog. I have pointers to that at the end. So let's do that. Oh. Let's see what happens. We're loading it. Nothing. We're not displaying it yet. So we're loading. We're not displaying. But it doesn't look like it threw an exception when it loaded. I mean, there was no error there. So let's see what happens. Here, what we need to do next is obviously render it. So that's my next hint. But we definitely need to render it. So, but, I tend to go in small steps. So I like to make sure that, I can load and things compile. And if they don't, then I can go fix it. So let's see if this fixes it. But before we do that, C++ people in the room? Anything stick out about this code? Any of you in the 20 modern Visual C++ tips 2 days ago? No. Range 4 loop. This is missing a range 4. There could have been a range 4 here, right? So let's go ahead and change this. Oh, yeah. My bad. It's been one of those mornings. So there it is. I'm trying to manipulate it here. Nothing's going on, obviously. We don't have anything wired up to do anything with this cube. And it doesn't look much like a die either, does it? Other than it's a cube. So we need to take care of that. So there are a couple things that we can take care of. It doesn't have a mesh. It doesn't have a texture on it, and we may be a little bit zoomed in. So what I can do is, it's pretty easy to go out and add a texture to this. So I have prepared. So I downloaded the texture. I'm going to go ahead and move it into our sample here. Should be able to find it here. So we've added it. This is what it looks like. I could have created this, but I took it. It is, I won't do it now, but it is pretty easy if you've got a template like this. If you wanted your die to look a little different, you go in and use this template and change it. Using your favorite paint program, it's pretty easy to do that. And then you can visualize it in these tools. So what I need to do is come back here, take a look at the properties. Texture 1. And it's that easy. So now we have a texture. Let's see if we get it when we run it. There it is. It is a little bit far away, though. Let's take care of that. So the camera is let's see if that makes things better. So we're a little closer now, but we're still not. When we tap the screen, ideally it would roll the die. We're not getting that right now, but we do have a nice perspective of the die. It looks to be correct. So what we need to do is animate this. No, that's not what I meant to do. Let's run it again. And for animation, it's just like you would expect. If you've watched Warner Brother cartoons or even Pixar cartoons, you have to know what your starting and ending points are going to be. And then at each step in between, given a time amount, right amount of time. So if you're going to animate over a half a second, you have to know what the terminal point looks like, the beginning point. And then at each interval in between, you got to be able to render that instant. So we're going to have to do that with this. And let's walk through some of that. By the way, for Warner Brothers cartoons, at least, that's where I learned a lot of animation stuff by reading those books. I was a big fan. The principal artists, like Chuck Jones, would do the keyframes, the beginning and the end, and they would have in-betweeners. Second-tier artists do the points in between. So they had big sheets that showed what the character looked like Bugs Bunny, in maybe 50 different poses. And then Chuck Jones would go in and write, draw the keyframes for the scene. And then the in-betweeners would come in and use those character studies to do each point in between, like walking from, maybe it's Bugs walking over to Daffy. And they would be in charge of doing that. In your application, you're both the principal artist and the in-betweener, so you have to come up with both. So what we're going to do is we're going to go to, we need some variables to track this. So we're going to have to go out and add that. So let's go do it. We're going to add. It's fun watching me cut and paste, isn't it? Let's do this. So we've added some variables to track, not only roll the die, but to track what our initial rotation is, what our target rotation is, that's where the die is going to end, and then at this moment in time, what is our current? And then we're going to add roll die here. And then we have to go monkey with our update. And again, update is given to you. So as part of the 3D starter kit, you get total time and what your time delta is when you come into update. That's what the framework actually sets up for you. So we're going to add code that says, if we're animating, what is our delta? And then we use that as a parameter and do a calculation to figure out what our current rotation looks like. And if we've reached the end, then we're going to stop. But if we haven't, we're going to continue. And then one final thing. We have to modify render to account for this. So let's go do that. Oh, I forgot to add the untapped. So let's do that. There it is. Let me get there. Oh. So it rolls once, and it goes to 6. There's no randomness there. But it is moving. So let's see if we can make it do more than that. Let's add some randomness next. So we will add randomness, but what's interesting is this may seem like it takes a while to get this stuff going, but anything that uses graphics generally will have some math behind it. This is a good demonstration of, this is relatively simple, but it can't get much more sophisticated. So for example, there was someone out there that has a extensive post about the game of Go, and he modeled the Go stone, and it's 3 or 4 posts about, not only how do you develop the stone itself by using overlapping ellipses, but tessellation, and then the physics, and then adding a little bit of randomness to make sure that the physics, when you drop this stone on a board, it behaves correctly. And it goes into quite a bit of math. And it was interesting to read that and went kind of some of the math. So what we're going to do now is we're going to use random generator. We're going to use a Mersenne twister for this. This sample, when you find this online, does not use a Mersenne twister, but we're all C++ people, and we use the standard library stuff. So we're going to go do that. First thing we need to do is modify game.h to include that. Let's do that. And then add a instance variable here. And then we'll initialize it there in game. And then we're going to modify roll die. So what this does is, based on the number that comes back, it chooses a target rotation, and it's got a definition of a transform of what that number looks like given the cube. So this is the transform matrix that you need to get to that point. That's what it looks like. So, and then what we should be able to do is hopefully run it, and it works. Unless I've made a mistake. Actually, I did. I know exactly what it is. Anybody want to guess on what it's going to come up at? The number? 6? 6. 6 it is. Now, TechEd North America, I did it a few times and it came up 6, and I said that, we're not cheating here. It's truly random, and it came up 6, and people just laughed. Oh, so it's not updating itself when I hit the button here. So we'll have to go in and take a look at that. So yeah, I forgot to take the code out. That's not why it landed on 6 at TechEd. Let's see. So here we go. So it is spinning around, and you can see sometimes it stays, sometimes it doesn't. some things a graphics debugger can't help you, and that's an example, logic errors, things like that. So the last step here is, the die is flat. It would be nice if, in the extreme, it would be nice if you could shake it and throw it and it bounced along a box or something. But here we're just going to make it pop up in the air. And we're going to make it pop up in the air in a realistic way. So we're going to use a parabola to describe that. I'll show you what that equation looks like real quick. We won't spend too much time on it. So under update, if we're updating, then we're going to modify the y component. And then under render, we obviously need to account for that change, the height. We'll do that there. And then under roll die, we'll tweak it a little bit to account for the height. And let's see if we've got it. Almost done here. So there we go. We are on our way to creating a simulation that instructs people on how to, or helps people learn a little bit about probability. So this was obviously a contrived example, and I had code. But this is something that I think is a good example on how the little steps that are required to do potentially a larger program. So now that we have it, we began with the starter kit. We created the die with a mesh editor. We brought the die to life with physics and C++. And let me show you one other thing before we move on. What's cool about this is the mesh editor. There are a couple other things you can do here. One of the things that I didn't go into that your application may actually need is, if we take a look at the properties here, there is a shader behind this. We can see that there's a Phong shader behind this, and if we click Advanced, in this particular case, we can see what that shader looks like. So this shows off the shader tool, and it's a graphic shader tool, so you can modify and create shaders graphically. This particular one is relatively simple. It controls lighting on the cube, but there are more advanced ones, and there are lots of things that you can do with the shader. And as an example, I went and talked to some folks and managed to pull I managed to get access to some cool ones here. Let's see. So let's see this one. So I know I need to zoom in here. Painful. So there's the final. If I hit the timer here, I missed it. Of course, I hit the thing that... You can see that it's working, right? The thing's spinning. At the end of each stage, you can see what each component does. So here, we don't have any color at all, but you can see that it's kind of put some definition there. Whoops. There. Pretty neat what you can do. There are examples of other things that you can do. There's fire effects. There are a bunch of other different effects that you can do. You can visualize a lot of them in this tool. I have talked to people that use these tools and then go on to do more advanced games. There is a point where you do go into hand coding, and that's where people generally stay when they get a lot more sophisticated. So there is a mix. You might not always use these tools, but there is a good chance at the beginning that you would use these tools, and as you get more sophisticated, you'll move on. But this is an example of what that looks like. So the next part of the demo is, let's pretend that we completed the app and it's in QA now. So I'm going to pull an old switcheroo here. I've got the same application that we just created, but I've secretly replaced your application with one that has bugs in it. So let's see what it looks like just running it. So there's a teapot. It looks like we have nothing, but it is the app that we created, but there's nothing there. So obviously we need to debug this thing. So the typical scenarios that people will use when they're debugging, we'll get in and debug here in a minute. Let's go over some of the scenarios. Is how is the device set up? You're going to want to, a lot of the errors that come up are device errors. So you haven't configured your DirectX 3D device. And there's a way to go out and take a look at that. That is one common error. You're going to want to see events for a frame. So when a frame is built, there's some subcomponent of that frame, that pipeline that isn't working properly. You'll be able to do that. You're going to want to see a draw event move. So if you're drawing a tank or something, there might be an issue. You want to visualize that. See the call stack. See how a pixel is changed by events. So this is getting relatively detailed, but if you're running a lot of transforms on a set of pixels, there might be one step that isn't working, and the tool will let you take a look at that. And then step through HL/SL code and analyze direct 3D objects and resources. The primary ways to debug DirectX 11.1 code are to capture locally using the Visual Studio Graphics Debugger. You can also capture remotely using an API. We're not going to demonstrate that. Now, how do you start the Visual Studio Graphics Debugger? Alt F5. You can also do it that way. So let's see what the errors are. We know we have an error. Let's see what they are. So if I hit Alt F5, we are running graphics diagnostics. And the telltale sign is, if you can see up in the upper left, you've got frame and some other information. To capture a frame, I hit Print Screen. And I've captured a frame. So let's go take a look at that. There we go. Had to have it stop. So here we can take a look at our device context. And, you know, everything looks okay. I'm waving my hands here. For our particular device, things are fine. Again, the graphics development kit, the 3D kit, is doing this for us. So we're reasonably certain that it works. If you go out and do this yourself, this is a great place to go out and make sure that you've got things set the way you think they should be set. What's interesting is there's no image here, right? I'm not seeing like a draw image. It doesn't look like it's even drawing the mesh at all. So let's go take a look and see and what might be the issue there. This is where we're loading the mesh. And the problem is that we've named the file incorrectly. And when I was talking to some folks when I created this, they actually, when they said this was a common error, I couldn't believe it, right? But in thinking more about it, when I write code, I make a lot of errors like this where I'm not loading something right or specify the wrong extension. This is actually relatively common. So this looks contrived. It looks relatively simple. But this is a common error with graphics programs that either the people that created the thing and export the assets to you change the name between the time that you completed the application and moved it on, or you inadvertently fat-fingered it in and it didn't work, right? You messed it up. This is a common error. So it looks kind of silly, but it is actually a common error. So this is going to get our mesh then loaded. Let's see if that improves things for us here. Still not seeing anything here. Let's do a print screen and grab a frame. Then I'm going to exit, go back, and let this thing stop for a minute. Let me close these. These are from our previous one. That's something else that threw me off. So, in fact, I may have closed the wrong one. Let me close this again. Try that one more time. It keeps previous debug logs open, and that always throws me off. So I should have closed it when I was done with it the last time. So let's go and take a look here. All right. Oh, ouch. Ouch. All right, let's see if we can pull that back. Ouch. That hurt. Let's see if it'll go one more time. And if not, all right. So we're trying to take a look at the pipeline. I don't know if people see at the top. It says that there's an issue because there's multi-sampling, and the DirectX toolkit does set up multi-sampling. It makes the graphics look better. Before continuing, what I want to do is I want to remove that. So I'm not going to do any more here. What I'm going to do is go remove that. And the way you do that, there are two places in here that you might be suspicious. There's one that says like set multi-sampling equals true. If you change that to false, it doesn't work. If you go in here and change sample count to 1, that will actually force it to use no multi-sampling, and then we won't get that error anymore. So let's go quickly take a look at that. So if I grab a screen now, there they go. So what's interesting is we see in the pipeline, we see that there is a mesh there. So it is being loaded. And then that's the shader. So that seems to be running. Oops. And that's where the texture is being applied. So it looks like things are going, yet we don't have anything in the scene. So there must still be an issue. Let's take a closer look and see if we can find it. I'm just going to cheat. I know where it is. So this is another contrived example, but it's common. In this, we set an explicit camera, but in a lot of times you'll use variables. And if one of your calculations goes off, your camera will be pulled way back, and you won't be able to necessarily see the image because it's eensy-weensy. So this is an example of that particular kind of error. If I come in here and fix this, it should go just fine now. So it's back, and it works. So again, there are more sophisticated debugging scenarios with graphics, but maybe 80% of the time, the kinds of things that we showed you today are the ones that are going to get you. So we have an app. How do we extend it? In what ways can we extend it? We could add more die and supporting objects. I think I already mentioned that you want to maybe shake them up and throw them into a box or something so you get bouncing against walls. You can see that if you add the bouncing against walls and the shaking and the flat surfaces, that our simple set of physics and math there to manipulate that would become a little bit more sophisticated. You could add sounds and music, maybe a little dubstep. Increase interactivity. Maybe there's a bunch of different die instead of just a 6-sided. You've got an 8-sided, and if there's Dungeons and Dragons players in here, 4-sided and 20-sided and 12-sided, you could have a good time with that. I will say that again, I'm a community guy, so I like working with all the information that's out in the community and the people that create it. Roberto Sanino, he actually works at Microsoft, created this, and he has an associated set of blog posts about this. And if you want to deploy the app and actually onto mobile, Windows, App Store, and phone, you follow this link. Roberto has a blog post on taking what we just created and deploying it there. There's also an interesting video if you can go to Channel 9. If you follow this link, it'll take you to Channel 9. There's an interview with Gökhan, the guy that created that virtual lab simulator. And he talks about some of the challenges of creating an app like this, along with some of the issues that he had in debugging. And then he talks about the pixel shader. So if you want to learn more about the pixel shader from someone who has actually done it, and you can actually see the app, this is a great place to go. And it's one thing to see, from my perspective, it's one thing to see demo of something that's kind of smaller like this, and it's quite a bit different to see something like a Hilo project. I don't know if you have seen this, but we've got a couple of other longer samples out on MSDN that are really big. They're really impressive, but sometimes it's hard to figure out where you want to start if you've just got a small problem and you're trying to render something and learn the ropes. I mentioned this earlier as well. You can learn more from the community. There are physics libraries and image tools out there. There are a lot of things out there that are provided by the community. Samples, code snippets, and frameworks. I know that there are a couple. We have DirectX MVPs. They're now C++ MVPs. But they have created a lot of information out there. There's also DirectX tutorial, which has some great free lessons as well that go over the basics of pipelines and things like that. It's very useful. You can get discussion, advice, and feedback in any of the forums. And I will tell you this. If you post questions to places like Stack Overflow or on our blog, if, for example, you see Roberto Sanino's post and you have a question about it, Roberto sees those and he will answer. And it's our pleasure to take your feedback and answer. We do respond. The Visual C++ team is very responsive. And if you send me a question, my email was there. I'll give it to you again. I will make sure that it goes to the right people and you will get a response. If you don't get a response, I go looking for people. So, I just go down the hall and bang on doors. And then it's important that you contribute. A lot of people say, well, I don't have enough to contribute. I'm just a beginner. It's not the case. That if you've had experiences with development, any kind of technical experience, someone out there can use your information. So you may think it's trivial or inconsequential, but I've seen time and time again that someone posts like a wiki post saying, well, here's how you do X in this weird scenario. And then it'll get 50,000 views after 6 months. Someone thinks that it's a corner case. It isn't a corner case. So if you learn a trick with a mesh or you learn a trick with a pixel shader, then go out and share that, and people will be happy to see that. And it builds your reputation at the same time. So I have a pop quiz. I have 3 questions, and I have 3 shirts to give away. How do you launch the graphics debugger? Okay. Come up afterwards and grab. Oh, here. Oh, as he drops behind the. Sure. Let's try my. How do you capture a frame? I'm not John Elway. I'm pretty sure I won't be able to make it all the way back there. Where can you share your development experiences? How about over here? Right here. Community. One more? Back here? Alt F5. So that's the end of the talk. Looks like we're MSDN subscription. Make sure you go out on the web and see the marketing site. They've got more information about the preview. Channel 9 is a great resource. So there's a TechEd resource there. If you're developers or developer bent, build Windows. Go to Channel 9 and also look at the build content there. Keynotes are online. And again, the C++ team, those talks are either going to be streamed Friday or today, later, or you can go out and see the presentations themselves. I recommend you do that. Evaluate the session, good or bad. and leave verbatims, leave the comments. So if you expected me to use F# and you were unhappy that I didn't, definitely include that in the note. Are there questions? Yes. I'm going to walk over here so I can hear you, and then I'll repeat the question.
Came in a couple of minutes late, so was this native or managed code?
It was native. It was C++.
Well, you have also managed C++.
Yeah, it wasn't managed C++. Yes.
This was native?
Yes, it was. Yes. Other questions? Okay. My email is at the beginning. It's ebattali@microsoft.com. I probably should have added it at the end. Here again. Definitely email me if you have any questions or feedback or comments. And thank you for coming this morning.